Warning. The video you're going to watch now is part of a thesis and an essay. Almost nothing that will be said has the official signature of astronomical science. Therefore, as these are new and purposeful ideas, you could frame this video in the field of science fiction. The author.
When you look at the sky during the day and see the sun strolling over the ecliptic, you do not notice any variation in its volume and brightness. The image of the sun, not the sun itself, performs an apparent circular motion in the sky that, actually, results from an extrapolation of the motion of the planet itself. That is, it's the Earth that moves towards the star, because the sun remains relatively still in relation to the planet. Possible variations in the density of the solar mass would be obscured to us by the time barrier. This barrier expresses itself in the delay to which the light of the star would be subjected to travel the distance of 150 million kilometers that separate us with its fixed and limited speed. This detail forces us to see the sun always outside its true position. These questions seem to be philosophical in nature, since they involve the observer's point of view. Those who work with science find this a waste of time. When I took the risk of delving deeper into the introspective path, contrary to what science usually does, I noticed that the point of view of the observer should not even directly influence the reality of the universe. However, it could lead us to understand how some forces act in spacetime, such as gravity. As a secondary or restorative force, it cannot be added to the other forces. The behavior of gravitational potential energy is compared, by physicists, to that of a spring. The force would be zero when the spring was in its resting position, and would tend to decrease negatively once the spring was compressed. There would not be, in space-time, a supposed phase in which this spring had been stretched beyond its resting position. In this official model, the expansion of the universe would be in difficulty. What caught my attention early on was the observer's dependence on cosmic radiation. That is, without the radiation we could not describe what would happen to the stars placed light years away. Our dependence on the constant presence of light to see the stars meant that astronomers could no longer treat space and light as independent entities. For example, if space bends, light is the same, and vice versa. Because of this apparent fusion between the two, the behavior of space itself is compared to that of an elastic strip. In fact, an elastic band, or a spring, are analogies commonly used to describe the simple harmonic movement performed by light. realizing these details, I felt as if I were at the entrance to Theseus' maze in Greek legend. In front of me was one end of the ball of yarn, handed by Ariadne to Theseus, so that he would not get lost in the maze. After killing the Minotaur, Theseus would have used the wire to safely return to the exit of the maze. I thought I should follow my intuition and slowly pull the thread of the ball of wool into the cave. From there, followed the texts that I posted on the ISA website and the videos released on YouTube, which address the reflexes that the observer's views would have on the interpretation of reality, not over reality itself. I noticed that, in assuming this attitude, I would not necessarily have to confront the laws of physics. Also, it would be important to try to scale the role of each of us in the way we interact with the reality around us. What was not my surprise, when I came across some evidence that suggested that our memory might influence the sense of action of some forces we see acting in spacetime, such as gravity. To illustrate, I will next suggest an unpublished model for describing the influence between the Sun and its planets. Since it is an essay, it would be advisable for the spectator not to take the model so seriously, at least until further evidence could corroborate it. When we look at the open sky, during the day, we see the Sun moving over the ecliptic, from east to west, forming a perfect circle. This circular movement is known to result from the observer's transfer of the planet's own movement. In fact, despite its own motion, the Sun remains still, relative to the Earth. The observation of the sky gives us the distinct feeling that we would be in the center of the universe, because everything seems to revolve around us. Johannes Kepler managed to escape the yoke of sunlight, which always shows us the Sun with the same mass and volume. By indirect calculations, Kepler proved that the actual movement of the planets forms an ellipse over time, not a circle. Without Kepler, we could not have succeeded in sending probes to the other planets. In any case, the illusion of circular motion is part of our physical reality, which suggests that light is not a good advisor. Even considering that, without the light we would have no way of knowing about the existence of the stars and planets in the solar system. Time makes sense to us when we find ourselves already looking toward our own past. It represents a real prison for our physical body, because our memory is inseparable from time. Time is the basic tool that underpins our interaction with the universe. All that exists is what can be remembered, or what is already in our past. You have already seen what Alzheimer's can do to us in the later stages of the disease. There is a moment when the patient is totally disconnected from reality, because memory suppression removes from him the only tool that allowed him to interact with his loved ones. Trying to escape the yoke of cosmic radiation, I collected data from science that points to a series of events that would be taking place in the sky above our heads. Those events would escape our most sensitive assessment methods. Besides the impossibility of describing the elliptical motion of the planets directly, since the ellipse would result from the sum of the positions occupied by a planet at independent moments of time, there are some other incongruities. For example, as the Sun would maintain the same mass and volume over time, it would always shut the same amount of light and heat into space, acting as if it were an incandescent light bulb. The gaseous or ice planets are placed so far from the Sun that, due to the fact they should be inert or frozen. However, the Voyager ships have noted a noticeable incongruity between the albedo of these planets and the amount of light and heat coming from the Sun, which they reflect into space. In the case of Jupiter and Saturn, they reflect up to 3 times more light into space than expected at those distances. If the energy radiated by the Sun were decreasing proportionally with the distances, there should not be enough energy to justify the high winds of up to 1,000 kilometers per hour found on Saturn. Without understanding why, scientists attribute the excess radiated energy to the planets themselves, which would have an internal source of heat. There are controversies